Hello, today I will be talking about the periodic table of elements. My name is Tyler McCowan, and I will be your guide to metals and nonmetals. May I see the iron, please? This is iron. Iron is a metal, and is typically found in a solid form. This is iron in a powder form. Metals are typically very shiny, they're durable, and they're malleable. Iron is a very common metal found in our earth, and it is used in different types of tools and machinery. Iron is highly magnetic. May I see the iodine, please? This is iodine in a liquid form. Iodine is hazardous to humans. Now, most nonmetals, they are brittle, they break easily, most of them are toxic, but they're used as insulators because they don't conduct very well. But most of them are found in our everyday life. And now we will be talking about the periodic table.
I'm Eric, and this is the metals of the periodic table. On the left side, we have the alkali metals, the first row, except hydrogen. On the second row, we have alkaline earth metals, and then from 3 to 12, we have our transition metals. Okay, so on our right side of the periodic table, we have our nonmetals. Right here, along this zigzag line, we have our metalloids. So we have boron, silicon, germanium, arsenic, antimony, and tellurium.
On the periodic table, there are groups and periods. Groups are the columns. There are 18 groups on the periodic table, and the group number tells how many valence electrons there are in each element. Periods are the rows. Go from left to right. There are 7 periods, and the periods tell the number of orbitals for each element. Here we have the basic structure of an atom. This is the atomic number, which will tell its placement on the periodic table, and the atomic number is also equal to the number of protons and electrons in an atom. Here we have the chemical symbol for the element. The name of the element will go underneath the symbol. Then we have the average atomic mass, which is the sum of protons and the neutrons in the nucleus. Here we have the temperature for the freezing point in Kelvin, and here is the boiling point. Now we have the change in heat of fusion and the kilograms per joule and divided by the number of moles. Here we have the change of heat evaporation and the kilograms of joules divided by moles. And then we have the oxidation state. The oxidation state tells how many electrons an atom gives or takes. And there is the density, which is mass divided by volume. This is the basic structure of an atom. Here we have the atomic number, which will tell its placement on the periodic table. Also, the atomic number is equal to the number of protons and electrons in an atom.
I messed up.
We both messed up.
You suck. I hate you.